All right, I'm back. So here we go. I want you to focus on this trinomial on the left column that I just wrote out in green. All right, x squared plus 2x minus 24. We cannot forget how to do our normal trinomial factoring, okay? So we need to find two factors of negative 24 that when we add them together will equal 2, okay? So let's get back to the basics here, all right? There's negative 24. What are the two factors of negative 24 that when we add them together to equal 2, all right? Because B is 2, all right? So factors of C that add up to equal B. All right, well, 24. We have 1 and 24, but here's the deal. Is this 24 or is this negative 24? It's a negative 24. It's got a minus in front of it, okay? So we need one positive factor and one negative factor. How do we know which one is going to be positive? The bigger one will be positive. We know that for fact because when we add them together, we're going to get a positive number in our second term, all right? If you don't understand exactly what that means, just follow the rule, all right? 24 is negative, right? It's negative 24, so we need one positive factor and one negative factor. When you multiply a negative times a positive, you get a negative, right? And to figure out which sign will be bigger, you look at this middle term here, all right? So 6 and 4, yeah. So we have 6 times, and it's going to be a negative 4, as I said, all right? 6 times negative 4. When you add those together, 6 plus negative 4, you get 2, all right? So those are our two factors. All right, now look at this right here. We have x squared, all right? So that automatically means that our first term of each of these is going to be x because, think about this, if we were to FOIL this, all right, if we were to FOIL this, x times x would be the first thing that we FOIL. X times x is x squared, right? So take a look at this for a sec because I'm going to FOIL this once it's done, all right? We put x plus 4, well, let me get my blue color out here, x plus 4. Excuse me, guys. I'm sorry. X plus 6. It's positive 6. You say plus. Yeah, there we go. X minus 4. All right. And I want you to look at this. When we FOIL this out, all right, I'll do it with orange. First, x times x gives us x squared. Outer, all right, x times negative 4 gives us minus 4x. Inner, 6 times x gives us plus 6x, which is why we have the positive 2x and not a negative 2x. All right, see how that's plus 6x. The bigger one is what gives us that positive 2 in the middle. And then finally, last here, 6 times negative 4 gives us negative 24. When we simplify the middle terms, which are like terms, we get x squared plus 2x minus 24. So why did I go through all this? Okay, this gives us back to our answer here. So this is the proper factoring, all right, without all the arrows and stuff. Okay, x plus 6 times x minus 4. Why did I go through all this? I want you to look at the first terms, okay? I'm going to erase all this. All right, I proved that. Boom. Look at our first terms here. X and x, okay? When we multiply them together, we get x squared. Now, I want you to focus your attention up to number 15, all right? Here we have n to the 4th as our first term, all right? So what number would multiply together twice, right? That is the same number that would give us n to the 4th. It would be n squared, right? And you see that right here, right? When we do the FOIL, when we combine our like terms, we're going to have n squared. So when we have this is kind of a special trinomial factoring. It's really not any different than what we just did right there. The only difference is we have n to the 4th in the front, which means that we need, instead of n plus n or n plus something times n minus something, right? We're going to have n squared as our first term, right? So n squared, parentheses, n squared, all right? So what are the two factors of 24 that multiply together? Well, we just did this basically the same one, right? So we know it's going to be positive 6 and a negative 4. So we finish this up. We get a positive 6 and minus 4. We put that into the parentheses. This is our normal trinomial factoring. The big difference here is that we have n squared because this is n to the 4th. So we know that it must be 2 times 2, which gives us n to the 4th for our first one. And that should match what we have here in the middle term, which is n squared. Does everybody see that? Hopefully you do. All right. So with that knowledge, let's go through this. Are we done? The answer is no, we are not done. All right, we're not done yet because look at the last video. We have a difference of squares here. That's a perfect square minus another perfect square. All right. So we have to figure out what a and b are. All right. Remember, this is a plus b, a minus b. This is nothing over here, right? It's nothing. There's nothing we can do with that. It's a perfect square plus 6, which is not a perfect square. It's a perfect cube. Doesn't matter, okay? So that one cannot be simplified, but we do have a difference of squares right here, so we can still simplify that. So let's go ahead and bring n plus 6 down, n squared plus 6 down. And we'll finish this one up. So this is our a term, all right here, and this is our b term. So here we have difference of squares, so we need to think in terms of square roots. So what number multiplies together twice to get n squared? N. So we have n plus what number multiplies together twice to get 4, which is our b term, n plus 2 times n minus 2, okay? And I didn't write out the a and things like that, okay? Whoops. And the purpose of that, again, look, once you get to a point, you're going to get to a point where you can actually just say, oh, this is my, oh, geez, did it again. This is my a term here. This is my b term. Square root of n squared is n, so we put that in the front spot, all right? Square root of 4 is 2, so we put that in the back spot, just using the formula for our difference of squares, all right? I didn't write that all out because I honestly don't have any space, all right? But again, that's our special factoring of that trinomial there. Let's go right to 16, okay? So we have w to the third plus w squared minus 20w. Now you might be looking at this thinking, oh, well, this one was this way, so this must be the same type of problem. It's not. All right, we have a GCF. Remember to look for GCF first, okay? So GCF here, they all have a w, right? So GCF is w. All right, so we're going to go ahead and put the w in the front and factor it out of each of the terms inside. So we get w squared plus w minus 20. And at this point, we just do our normal trinomial factoring. What are the two factors of negative 20 that add up to give you, this is a 1 here, okay? Add up to give you 1, right? So we end up getting 5 times negative 4. 5 times negative 4 gives us negative 20. 5 plus negative 4 gives us 1. All right, so when we write this out, that w stays on the outside. And we use our normal trinomial factoring. We know which one's going to be plus and which one's going to be minus. So w, because this is w squared, we know it's going to be w on our first term because w times w gives us w squared. All right, so w plus 5 times w minus 4. And let me erase this so I have some space here. All right, we end up getting w, geez Louise, w minus 4. We are done. There's no difference of squares, no difference of cubes, no trinomials that we can still factor. All right. Let's go down to number 17. All right. Going to go through this quickly. We've done problems like this in the past. Our GCF we need to find first. All right. There was no GCF for this first problem here. All right. So we didn't take it out, of course. So GCF here, though, is 2a. All right. 2a. Got to be able to identify that. And you don't have to identify it quickly, but it'll obviously certainly help. All right, so 2a is our GCF. I'm going to put that on the outside. We're left with a squared plus 19a plus 34. They're all plus, so we know that, again, these are going to be two positive numbers that we're looking for because now we're looking at trinomial factoring. Can this be factored? It doesn't really look like it right now, but let's see. We got 17 times 2. 17 times 2 is 34. 17 plus 2 gives us 19, which is right there. So let's finish this up. We're going to go ahead and keep that GCF on the outside and then just do our normal trinomial factoring. A plus 17 times a plus 2. And if you need help with normal trinomial factoring, remember when we did that, we actually did watch the Yay Math video, and that, I think, is a great video of normal trinomial factoring. So, again, I will send a link to Yay Math, and you guys can have a field day with that. All right, let's look at number 18. Do we have a GCF? Always talking about that first. GCF is x, right? So we're going to take the x out, divide everything by that x. We get x to the 4th minus 24 x squared and then minus 25. All right. So this problem should remind you of this problem right here, right, where we have n to the 4th. Now we have x to the 4th, right? And again, look at this middle term. We have n squared, and then no n at all in the back here, right? So what does that mean, right? Again, the x is still going to be on the outside as far as our GCF, right? That always stays on the outside. But we know that our first terms are going to be x squared and x squared for our first terms in our two binomials after we factor the trinomial. So what number multiplies together twice to get negative 25, but adds up to get negative 24? We got negative 25 times 1, right? Negative 25 times 1 gives us negative 25. When we add them, we get negative 24. So we end up getting x squared minus 25. Should ring a bell right about now, right? It should be looking kind of like, I don't know, maybe a difference of squares, right? And then we have x squared plus 1. All right. Do we have a difference of squares? Yes, we do, right? This right here is a difference of squares, all right? So I'm going to kind of mess with this on the side here, okay? We have this side area. So a will equal, what is our first term, right? Our first term is x squared. What number multiplies together twice to get x squared? That's x. And then our b term, right, if you're looking over here on the side, b term is 25, right? These are a and our b terms, right? But we need to square them because it's a difference of squares. We need to take the square, not square them, excuse me. We need to take the square root. All right, so square root of 25 gives us 5 because 5 times 5 is 25. So now we have to use our formula, all right, which, if we're doing different squares, is a plus b times a minus b. Okay, so let's go ahead and do that. X times a plus b. What's a? A is x. X plus 5. X minus 5. That takes care of this. This is done, right? This is now x plus 5, x minus 5. This right here, can it be done? We have two perfect squares, but it's addition. It's a sum of squares. There is no such thing as a sum of squares, so that can't be simplified. All right, so we are all set. We're just going to carry that down here. X squared plus 1. All right. Excellent. That's it. All right. That's it for these. Well, it's not it. We still got some more to go. All right. 19 and 20. All right. This is one of my favorite types of problems to do for factoring. Right? I just think it's kind of unique and interesting how the math works. All right. I'm a huge nerd, so there's that. All right. So let's go ahead and do this. All right. What's the problem here? All right. The problem is A is not 1. Right. A is 3. And I'm trying to underline it, but I'm erasing, so it's not going to work. There we go. A is 3, right? A is greater than 1. It's the first time we've ever had a problem where A is not 1, right? And there's no GCF, so we can't take it out. So normally we would look at this and say, we can't factor it. But the fact of the matter is, of course we can, right? Of course we can. Sometimes we can't. Actually, most of the time we probably actually can't because it's prime. But these problems here, these examples, they're not going to be prime, right? So what do we need to do? All right, so I'm going to kind of give you the steps here. First thing we need to do for these problems, 19 and 21, is get rid of A by multiplying A times C. All right, so we're going to get rid of A by multiplying A times C. So what I like to do is put that arrow there and say, let's get that A out of here, right? We don't like A's. All right, so let's get the A out of here if it's not 1, all right? So 3 times negative 5, and we're going to rewrite it, okay? 3 times negative 5 obviously gives us negative 15, right? So that is going to be our new C, all right? So we rewrite it as this is gone, all right? We've moved this and multiplied it. So now we have x to the 4th plus 14x squared minus 15. Hey, oops, that is x squared. Hey, look at that. We got a trinomial, and we know how to factor this at this point, right? Even though this is x to the 4th, right? That might be a little bit different than we were used to in the past. We proved up here this problem, right? This problem right here, right? All dealt with x to the 4th, right? So again, all that means is our front terms for each binomial is going to be x squared, and we know that because we can see this as x squared, okay? That's your signal right there, okay? Is you see this and you go, ooh, okay, x to the 4th. So this could be x squared, right? We look at this middle term and notice that there's no x here, right? So that's good. That means that this is going to be 2x squareds in front. So I'm going to put x squared Let me make this a little bit closer here, just spatial-wise. X squared. I guarantee they're going to, well, maybe not. We'll see. They might give us a difference of squares or something like that, okay? So now we got to factor this, okay? So two factors of negative 15, that add up to be 14. Well, 15 times negative 1 gives us negative 15, right? But when we add them together, we get a positive 14, all right? So hopefully you guys have gotten pretty good at that, all right? So we need to put x squared plus 15 and x squared minus 1, all right? Now, here's where we're at, okay? We're not done yet, but this is the part I like, all right? I'll just put 2 here, factor, normally. After you do the a times c, factor trinomial. And then 3 is a pretty cool step here, and I'll do this in red, all right? Our last step is to divide a to back term of each binomial. I apologize again for the handwriting. Looks like a third grader that is riding a roller coaster. All right, so what was A? A was 3, right? So we just take that 3 that we originally got rid of, and at the very end of this, we just got to bring it back, all right? We got to divide our last term to that, all right? So we're dividing the last term. Now, last thing, once you divide it to each term, we have to simplify, and if there is still a denominator, we move it to the front. So 15 divided by 3. What is 15 divided by 3? 15 divided by 3 is 5, right? So this one finishes up as x squared plus 5, right? You can see 15 divided by 3 is 5. Right? And then this one here is x squared minus 1/3. I said simplify it, and if there is still a denominator, then you have to move it to the front of that binomial. All right? So is 1/3 simplified? Can we simplify it any further to get rid of the denominator? No. So what we need to do is take this denominator and move it to the front of this binomial, and we are all done. So we end up getting 3x squared minus, and now that fraction is gone, minus 1, because we moved that to the front. Now, if we did FOIL, now you see how this works. 1x squared times 3x squared gives us 3x to the 4th, like we have up here at the top. You can go ahead and FOIL this out if you'd like, just to prove that this is the final answer. 100% is, all right? So that's how it's done. And really, it's not as complicated as maybe it seems. All we did was first take away a, and then finally then factored it normally, and then brought it back, right, at the very end of this. Simplified the fractions. If there was still a denominator, just move it to the front of that binomial, all right? All right, cool. Let's do number 20. All right, first is get rid of a, all right? So we end up getting, let's get this 9 out of here. Gone, all right? 9 times 4 is 36, so we get m to the 4th minus 12. Why are they giving us all these m to the 4th things, man? Oh, challenging us. I see. All right, so plus 36, right? This now becomes 36 when we do 9 times 4, all right, which is nice. It takes away that a so that we can end up factoring this, all right? So just factor as normal, all right? Let's see what two numbers multiply together to get positive 36, but add to get a negative 12. All right. Well, both these are going to have to be negative, so that when we add them, they're both negative, and when we multiply them, they're both positive. All right. So that should be something you're hopefully thinking about here. So negative 6 times negative 6. All right. So this is m to the 4th. So again, we're going to need m squared as our first term here. M squared minus 6 times m squared minus 6. All right. So those are our binomials. All right, those are our binomials right there. I'll put this in a different color so that we have them. Negative 6 times negative 6. Doesn't look like a 6 at all. Looks kind of like a field hockey stick. All right, and we're going to go ahead now and do what? Put our a term, which is right there. We're going to divide it to the back end of each of these. All right, and that was 9. All right, so now we have 6 over 9. All right, now we need to simplify them. When we simplify them, I wish I could zoom. All right, 6 over 9 becomes 2 over 3. All right, same thing happens here, obviously. 2 over 3. All right, so now we are left with a denominator for both of them, and that's totally fine. It just means that we need to move that denominator of 3 now that's left after we've simplified it to the front. So we end up getting 3m squared minus 2. You got to keep that minus sign there, minus 2. And then, of course, this will be the exact same, 3m squared minus 2. All right. That's our final answer. It cannot be factored any further. There's no difference of squares, no sum of cubes, none of that. All right. So those are, I guess, really our 2 or 3 different types of factoring trinomials. Honestly, the GCF ones, like number 16 up here, we've seen things like that before. We've actually had those on tests and quizzes. But I understand that, 15, 18, 19, 20, they're a little bit different. Again, just follow through those steps. Remember that for 19 and 20, if A is not equal to 1, right, you multiply that last term, right, or multiply A to the last term, factor as usual, and then bring that A back in, divide it, simplify. If there's still a denominator, you got to put it to the front of the binomial. All right, let's use grouping. Grouping terms, all right, so steps. 1, group the first 2 terms together and the last 2 terms together, all right? So first 2 terms, all right, we're going to group them. Boom, boom. And then it says the last 2 terms. Boom, boom, all right? So we put parentheses around them, okay? It says factor the GCF for each group, okay? So for the first one here that we have, all right, x squared is our factor, our common factor, our GCF. It's the biggest common factor because we also have x as a factor. It's not our greatest common factor. All right, so x squared, and we end up getting x plus 1. All right, and then for the next one, right, we end up having minus 4x. In fact, you know what I'm going to do here? Since I can do this on this, I'm going to put our GCF in green here. All right, make this x squared. All right, so I'm going to put it in green. And there's a method to my madness here. Now, very important, if the first term is a negative, all right, you always pull out a negative, all right? You always pull out a negative GCF, okay? So if we're looking at this, we could say this as these two have a GCF of 4, but because the first term's negative, just make it a negative 4. So it's x squared minus 4, right? X squared in the front there. We have minus 4 as our GCF for this back binomial, okay? And then we got to factor it out. I'm going to use red, Christmas time. All right, x plus 1. Now, the reason I use these colors, you notice that these are exactly the same. Right? If they're exactly the same, that means you did it right. Well, it doesn't necessarily mean you did it right. It means it's not prime. It means it can be factored, so that's good. All right, all we need to do is combine those together as 1. Right? So I'm going to go ahead and do that. This is going to be x plus 1 in the front. You don't need to make it squared, all right? This is grouping. It's a little bit different, all right? It's not x plus 1 squared. Don't get into that habit. It's not for this, okay? I know we've seen that in the past. That is not what we're doing here, all right? And then if you see the green terms that I have, x squared minus 4, that is going to end up making our final binomial. And I just put them together, x squared first, and then minus 4 second, into a binomial. And if you are looking at this, you should be able to recognize that this is a difference of squares. So that would, and I'm not going to do it right here for this part just because I definitely don't have the space, but that's going to end up becoming x plus 2 times x minus 2, right? Difference of squares. And so you can go back and look at the video if you're still struggling with that a little bit. All right, so that wouldn't quite be done, but that is the basic idea of this. All right, so we'll do a couple of examples here, and we'll call it an evening. All right, so group the first 2, boom. Group the second 2, boom. All right, so x squared is in our front, all right, and then what's left inside, we get x minus 1. Let's look at our second one. 9 is plus 9. I'm going to put a plus 9 there, so just because it's positive, right, it's going to give us our next binomial, so it's very helpful. And then we finish that up, we get x minus 1. All right, they're the same. All right, so if they're the same, just write them once, x minus 1, and we are left with times x squared plus 9. And we're all done. Because even though this is a perfect square and this is a perfect square, it is not, there's no such thing as a sum of squares. All right? It's only a sum of cubes. And these aren't cubes. They're perfect squares. So we can't factor that any further. It's prime at this point. All right? So great job. Let's go ahead and do number 22. I got less than 5 minutes left, so we're going to crank these out. All right? Boom. Boom. All right? I'm not going to use different colors here at this point. All right, hopefully you can just see that the binomials are the same, the exact same ones. Okay, so let's take out a k squared in the front here. And we end up getting k plus 5. And then let's take out, our first term's negative, so we need to take out a negative number. However, do we have a GCF? Well, if there is no GCF, remember, technically there is, all right? 1 would be your GCF. So in this case, what's the GCF? 1, but we want to take out a negative because the first term is negative, so we're going to take out a minus 1, okay? Minus 1, and that will leave us with k plus 5 once we divide minus 1 to both of those, okay? And that's in parentheses. So we are left with k squared, k plus 5 we can put in the front. And I'm making this small so that we have space because we are not done yet. And in this parentheses, we get k squared minus 1. All right, where did those two come from? Right there. Right there. All right. So these are our first binomial. Right there was combined as 1. And then our second one, boom, k squared minus 1. All right. What do we have here? We have a difference of squares. All right. So at this point, a will equal what? A equals what number multiplies together twice to get k? Squared is k. What number? Yeah, it's the worst k I think I've ever drawn. We'll just leave it like that. That's an h. Dear Lord. There we go. That's a k. That's a k in every language. All right, so here we go. B. All right, what's our b term? B. What number multiplies together twice to get 1? All right, it's 1. So there we go. So we finish up with k plus 5 times k plus 1. K minus 1. All right. That's done. All right. We can't do anything else with that. So I'd box it, but I feel like I'd probably go through number 24. All right. Let's go ahead and do number 23. I'm going to go ahead and group the first two, group the second two. How do we know that this is going to be a grouping type? Because there are 1, 2, 3, 4 terms, okay, if you see that for each one of these, right? 1, 2, 3, 4 terms. 1, 2, 3, 4 terms. They all have 4 terms, okay? So that's what we're looking for here, all right? 4 terms, and that tells you that you can use the grouping method, all right? So and it's got to be in standard form, all right? Notice that all of these are in standard form. If it's not in standard form, the grouping method won't work. All right. Standard form means what? It means that our exponents are in order of least to greatest. It's probably the last one I have time to do, so I'll do this one quickly. What is our GCF for the first one? They both have v. They both have v squared. All right. So v squared is our greatest common factor. So we're left with 4v minus 5. Here for this one, hey, look at our first term. It's negative. So we're taking out a negative 4. All right. And we are left with 4v minus 5. Again, unless it's prime, they should be the same. So there we go. We're going to write that one out. It doesn't matter what order you put these in, honestly. You could put v squared minus 4 first. I just tend to put these together first. All right, and then I'm left with v squared minus 4, which, again, if you're looking at this, anytime I'm doing this, I always think, do I have a difference of squares? Yes, right? A would be v, and for this one right here, a would be v, b would be 2 because 2 times 2 is 4, b times v is v squared. So let's rewrite this out and we call it a day. 4v minus 5 times difference of squares, v plus 4, v minus 4. All right, and I don't want to forget our sponsor, flannel t-shirts. Cool in fall, not really cool any other time. Just kidding. I'm wearing one right now.